Hello there, welcome back to Petrophysics Rocks. We're in the mean streets of petrophysics today, life in the real world. I was out at an industry event last week and one of my many fans, my many 630 subscribers and admirers came up to me and said, where's your next video? I'm waiting, bated breath, paused over my LinkedIn keyboard waiting for the next video to drop. Where is it? And I thought, oh yeah, he's got a point. I've kind of fallen into a bit of a rabbit hole, I'm afraid. I was putting together a course at the beginning of the year to try and teach some petrophysics. And as part of that work, I thought I'd put together an Earth model in Excel and then log the Earth model and then give the class the logs and see if we could run some analysis and then see how close we got back to the original input answers, and then we'd use the variation within the group to investigate things like uncertainty and stuff like that. So that was the theory, and I've been putting it into practice, and I thought I'd revisit that work for my next YouTube video. And I'm kind of like 2/3 of the way through it now, but I thought I'd put out this intermediate video as a kind of a teaser, and to encourage you to like and subscribe down below, click those notification buttons or whatever it is you do, and then when the proper video, the full video finally drops, then you'll be notified and you can see it straight away, and then maybe we'll have a discussion about where to take this kind of thing. So what I've got here is the first part of how I'm creating an Earth model in Excel. I thought I'd do Excel as the sort of like the lowest common denominator amongst everybody. And then if you're somebody, a sedimentologist or a field geologist like Steve Adams or Mark Bentley, perhaps you'd like to give me a call, and maybe if you've got a measured section of stratigraphy or a sedimentological log, maybe we could make some pseudo logs up for it. And as I say, the idea behind my course was going to be let's interpret the pseudo logs, but I'm building this another Excel beast, and of course life in the real world takes over, and I don't quite get around to finishing it. I'm off to Poland at the end of the week, so I'm trying to squeeze it all in. But I thought I'd give you this teaser, and you can see whether it piques your fancy or your interest, and then we'll come back later, hopefully before Christmas, to get the final monster spreadsheet up and running. And I'm not sure how I'm going to do it, whether I'm going to give a copy away or whatever. I think probably I might need some donations down to the Aberdeen Archie Royal Children's Hospital, Royal Infirmary. Maybe you need some donations there or whatever before I give away a copy. But we'll see how we get on if and when I finally get it finished. But in the meantime, hope you enjoy petrophysics. Let's have a look and see what's coming down the petrophysical pipeline and see where we get on. Remember, like and subscribe. Hello there. Welcome to the Earth model that I'm creating in Excel, my Excel toolbox, just to play around. I'm in the halfway through this sort of process now, and this is where I started, as I said a couple of months ago with my Earth maker. Here's my model that I set up. I'm just sort of giving it a top depth of 10,000 foot. I've got a cap rock thickness of 2 foot. I've got a sand interval. I'm just making 50 foot of log just for simplicity as we set this things up. And I've got it set up for 3 beds. So this is kind of like an Earth model that I'm creating. Here's a V shale in the first column. Sorry, you can't see the titles very clearly potentially. I've got the V shale portion, the porosity track, if you like, and then the water saturation track, and then a permeability track, formation permeability that I've created with the model, and I'll show you how I roughly got this far, if you like. So here's the geometry of the model. I've got these 3 beds, 3 sand beds, 8 foot approximately thickness with a standard deviation of 2. In fact, if I go back to 0, well, it's got to have some value in it, make it 0.001. Okay, so these are pretty much average. The average bed thickness is 7.99999. So all 3 beds at 8 foot. But what I've tried to do with this code is I've said, okay, well, not everything has to be 8 foot. So let's give it that standard deviation of plus or minus 2 foot. And you can see that one's 7.3, 11.6, 5.9, and the average is 8.2 in this case. And every time you press F9, you get a new realization. Okay, and so what happens if I want a bit more cap rock thickness? So let's have 5 foot thick. So that moves the whole model down an extra 5 foot. And I say I don't want three beds. Say I want to have 8 beds. So 8 beds. 8 beds. Okay, now I can't fit those in. So let me make those 4 foot thick. So let me see how we get on. So I've got 8 beds of 4 foot thick. Just to double check that, let me just put that standard deviation in there. So there you go. 1, 2, 3, 4, 5, 6, 7, 8, just off the bottom of the scale there. So that's my Earth model, if you like. So let's put that plus or minus 2 foot thickness in there. As I say, you can see, oh, there's a negative thickness bed. Let's have an F9 so you to refresh that. Refresh that a couple of times. Yeah, I don't get that negative time there. So you've got 8 beds in the model of various thicknesses. And as I say, my idea is that if I ever get around to running this course, I'll just sort of say, well, how many beds do you want? And we can play around. I might give one person some really thin beds. You know, so maybe 1 foot beds. That doesn't, yeah, or 2 foot beds. You know, so we can play around, and I can give participants in the course different models or whatever. So that's the geometry, if you like. 8 beds, 4 foot thick, plus or minus 2 foot. And here you can see I've populated it with some properties. So where have I got the porosity and the water saturation from? Well, I've got those from over here in my Earth model. I've put some petrophysical constants in there. I've decided that I've got certain number of density properties, neutron properties, and sand properties. So I've given it a sand relationship. In fact, I've put a depth relationship in here. But anyway, you'll hear more about that later when we come on to do the if I ever get around to doing the final video sort of stuff. So here we are. We've got some properties, petrophysical properties, which I use to build these logs. And a bit down here, I've got an Archie saturation, which I use to back calculate my resistivity. And I've got a J function just to keep Danamara happy. I'm using a J function, and with my pore-perm relationship, I calculate a water saturation from whatever free water level I set here, and it populates the saturation and the permeability. So obviously these don't look particularly realistic. So I think when I give them to my future students, I've got some standard deviations in here. So I'm just going to copy these standard deviations into here. Boom. So you see, put a bit of noise in them, and I put the other standard deviations in this column here. Boop-a-doop. Copy. Put them in there. So what I've got here, obviously off-piste in another tab, I've got all the noise associated with density log readings and neutron readings and sonic log readings, and also a bit of noise in my Phi-T sands. So I've said actually I'm going to have 4 pu of variability in my sands. If I change that to 0.02 pu plus or minus 2 pu. Whoops, what happened there? Let me press the F9 again. Get my logs back. Oh, sorry, I put 20 pu. That's not so good. Finger 0.02 pu. There we go. Back again. So anyway, I put a bit of geological variability. Normally, plus or minus noise is 1 or 2 pu, but with a bit of geological variability for this particular example. Oops, I mistyped it again. 0.04. That's how much my logs vary. So with this, this is kind of zoomed in, so it's quite noisy. If I was creating 100-foot of logs, it would look a bit more natural, presumably. And with my permeability, let me put in let me put in Control C, put a bit of noise in here in the good sound one, and a bit of noise in the 0.4 of a decade. So we've got some more realistic looking core data now, and with that we calculate the J function, and this creates this pseudo log of this is our Earth model, if you like. So with that, I kind of go back here, and with that I can back calculate what the log response would be. So here you go. Here's what the pure log reading would be at this resolution. And then with this Earth model, I take this and then let's log the data. At the moment, I've just basically, if I toggle between the two, I've just I've put in a 1-2-1 filter. After my last discussion, after my last thin bed video, I got in touch, or Richard Bateman, in fact, got in touch with me, and we had a little bit of a discussion about the thin bed methodology, my last video. And he actually, during the course of that conversation, provided me with the 6FF40 induction log kind of tool response, which I haven't coded up here just simply for simplicity. I thought I'd get the whole Excel beast working, and then I'm going to put in the responses if this was an old, a normal 6FF40 type induction log, which for the purpose of this is fine. I mean, I might put an array one in there, but in fact, if anybody out there has an idea of the proper tool responses of this is the sonic log here that I'm calculating, density, neutron, gamma ray. I've just put in a simple 212 filter here to go from the Earth model to the log response. But if anybody out there could save me a bit of Googling and send me what would be a reasonable tool response for the gamma ray, the correct weighting potentially, and maybe if Darwin Ellis is out there, he could probably tell me about the density and the neutron tool response. I'm just creating the log at the moment at half-foot increments, not the original logging increments. So for the purposes of this demonstration and teaching lesson, I'm going to just use create a half-foot Earth model. And so if somebody had the correct weightings for the various tool responses, that'll save me a bit of Googling. Okay, and so as I mentioned before, the idea is then that we take these logs and then I supply you the tools, and we go through how to analyze these logs. And my idea was that if everybody in the class has slightly different set of logs, but I know what the original Earth model says, let's see if we can analyze the logs to come up with an interpretation and see how far out we are from the original Earth model. And if we have 6 or 8 students in the class with 6 or 8 different log realizations, then how close does the average get back to the original Earth model? So, and I thought we'd use that as a way of getting into the uncertainty side of things and playing around, and we can tailor the reservoirs to whatever your favorite reservoirs are or whatever. So as I say, this is still work in progress. I won't show you the next CPI slide, but it's got an interpretation slide in there that has slidey bars in there that you can see the interpretation changing as you move the arrows. But let's see how that works when I'm screen recording it. But anyway, back to the Earth model. This is where I wanted to be. So I'll just sort of let you know that things are progressing, and hopefully see you on the next video. And if you just click the like and subscribe button down below, then you'll hear when I upload the next video, which hopefully will take us right the way through from Earth model into petrophysical analysis, and I'd probably check it with some real data as well. I might I've got to build the template to load up some LAS file and calculate some real data as well as this pseudo stuff. Okay, as I say, if you give me a like and subscribe, comment down below with some weighting factors for those log responses, that would be appreciated, and hopefully see you next time back on Petrophysics Rocks. Okay, thanks a lot. Cheers.